Hello everyone. Bota is a personalized mobile application that helps to promote sustainable waste management. I'm Banu Chitra Sorliraj. My co-authors are Tolulop Olagunju, Mako Chinago, and Rita Archie. Here I provide the overview of the presentation. First, we start with motivation for the study, the goal of the paper, the methodology we employed, how we review the existing mobile applications, the results, the design of medium fidelity prototype, the evaluation of medium fidelity prototype, the design of high fidelity prototype, feedback generation for the high fidelity prototype, and iteration, finally the conclusion and future work. The motivation of the paper is improper waste disposal is a leading cause to pollution. What is improper waste disposal? Say, for example, if a truck full of recyclable paper has more than 0.5 percentage of contamination, say for example a stained coffee cup, the entire truck will be sent to the landfill and all the paper will not be recycled. This is one example of improper waste disposal. Studies show that lack of awareness and negative attitudes are problems in achieving efficient waste disposal, and there are little improvements that have been made to change the behavior of people. As we carry our mobile phones with us everywhere and all the time, there is a need for an approach using mobile app and persuasive technology. And we wanted to design a personalized mobile application to promote sustainable waste management behavior like waste sorting, responsible disposal, and waste reduction. The goal of the paper is to conduct a systematic review of mobile applications that are currently in Google Play Store and App Store for sustainable waste management, identify the persuasive strategies and code them using the PSD framework, build a medium fidelity prototype from the review results, evaluate the medium fidelity prototype, build a high fidelity prototype from the evaluation results, and then improve the high fidelity prototype from the feedback. The methodology employed in this paper is to search for waste management apps in Google Play and Apple Play Store using keywords like waste management, waste disposal, sustainable waste, waste tracker, and waste recycling. Categorize the apps based on the purpose of the app and what is the target behavior they are trying to achieve. 3 reviewers will code the apps using PSD framework, list most frequently used persuasive strategies, build a medium fidelity prototype with the frequently used strategies, evaluate the medium fidelity prototype with participants, build a high fidelity prototype from the evaluation results of medium fidelity prototype, evaluate the high fidelity prototype and get feedback, and then improve the high fidelity prototype. We use the persuasive system design framework for coding the apps. The framework has 27 strategies split into 4 categories, namely primary task support, dialogue support, system credibility support, and social support. The process for coding the app is first to install the application in an Android or iOS mobile phone, navigate and use the app features and identify all the persuasive strategies and how it is implemented and record it in a coding sheet, and compile the coding sheet from 3 reviewers. For the prototype design, we first design medium fidelity prototype from the results of app review, evaluate the prototype with participants, design high fidelity prototype from the results, and then get. For the app review, we search the Google Play Store and iOS App Store and retrieve 244 mobile applications, 81 from iOS and 163 from Android platforms. We removed the duplicates of 17 mobile applications. These apps were found both in iOS App Store and Google Play Store. After removing duplicates, we assessed the app for the eligibility. That is, we looked into the description provided in the store as well as the demo and screenshots. We excluded 79 applications. 17 of them were not functioning, 28, we cannot log in. 14, the target behavior was not in line with our research. Two of the apps were not in English, and 18, they were removed from the store after we started a review. And finally, we focused on 148 mobile applications. From the results of the review, we figured out 837 strategies cumulatively from the 148 mobile application. Among those, reduction is the most commonly applied strategies found in 97 mobile applications, followed by personalization found in 90 applications, followed by real-world feel and surface credibility, which is used in 83 mobile applications, and 73 mobile applications used reminders, and the rest of the other strategies and their count is listed in this graph. So how are these strategies employed? We explain it using one of the four commonly found application types for waste management. They are waste collection and disposal, personal tracker, gaming, and informational mobile applications. Reduction and personalization are most commonly used persuasive strategies. Explain how these are implemented. Suggestive search box, calendar view, map representation of nearby centers, or how the reduction is employed in waste collection and disposal apps. About personalization, the content is showed based on the current GPS location of the user, and the time of the reminders can be personalized. For the personal tracker, reduction is employed in the form of login using social media and one-step entry for the item which they want to track on a daily basis, and simple suggestions which they like, simple action which they can perform on their day-to-day life. For personalization, each user is provided with a profile, their personal goals, tracking, and customizing the reminders. For the gaming apps, reduction is employed in the form of motion sensing, where the user just have to use their they just have to shake their mobile phone to move the garbage bin to catch the garbage which is falling from the top. For the personalization, the levels can be personalized based on the easy, hard, or medium levels. For the informational apps, reduction is employed in the form of list view, which shows a summary of the feed information which they are getting, and short quizzes. For personalization, they can subscribe to the feeds based on their personal interest. This is a medium fidelity design. We designed one screen for the nearby recycling centers, which shows based on the current location of the user, it shows what are the recycling centers which is available around them, or they can even book a pickup where the center can come and pick the recyclables which they have at home. The second one is the daily tracker feature, where they can track whether they didn't use the plastic bag, how much they recycled, did they produce organics, manure, the awards which they receive, goals, news, tracker, graph, and calendar. The fun zone has a sorting game for which they can share their high score in Facebook, Twitter, or the social media platforms. For the campaigns, it shows a feed of the events which are happening near them. The events are related to waste management like beach cleanup or trash tap, or it can even connect with friends who have a common goals like a goal of reducing plastic waste. To evaluate the feed infinity prototype, we asked our participants on questions on how they will dispose each type of waste. 75% of the participants had good knowledge on how to dispose the organics and electronics, but their knowledge wasn't pretty good when it came to recyclable plastic and single-use plastic. Only 38% of the participants knew how to dispose of recyclable plastic, and just 13% of the people know how to dispose of single-use plastic. We asked the participants to play a game, waste sorting game, which is rethink provided by the local government in Canada, Surrey City. 75% of the participants said a game like this will improve their knowledge in waste sorting. and 25% disagreed with that. The participants were shown the pictures of medium fidelity design and asked to provide a rating on a scale of 5. Then the cumulative rating is used to provide the app feature score. Nearby centers and games scored well, daily trackers scored 30, and campaigns were just scored 28. As all the features scored nearly the same, we decided to implement all the four features. This is a high fidelity design. The first screen is a login, which also provides the user the redaction of login using Facebook. They can sign up if they want to, or they can provide their email or phone or password to login. This is the home screen of the mobile application. It has four primary features. First is the daily tracker, next is the recycling depots, third is the sorting game, and then news and events. The nearby centers shows a color-coded information where a red color geotag shows it is a recycling center for organic food, yellow is for paper or glass, blue is for plastics, and black is for multiple types of waste disposal. This map is displayed based on the current location of the user. The next screen is the daily tracker. It shows a calendar view and a log data log where the user can log how much waste they disposed with regards to food waste, plastic, glass or paper. They can choose whether they reduce their food waste, recycled food waste or reused food waste. The same applies to plastic, glass or paper. Their progress throughout a week will be shown on the calendar view. For consistent performance, the user is provided with an award badge. Next is a newsletter. It provides a list of newsletters or feeds based on what the user is subscribing. They can save their favorites or they can follow the Bota app in Facebook, Twitter, or using their website. The next is a competition with friends. As a user keep tracking that they didn't use a single-use plastic, they keep competing with their friends which they can choose. So the more number of days they don't use a plastic bag, they score well. The last is a waste sorting game where the user is provided with a waste type and they'll be asked which bin they will have to choose to dispose the waste. The green is for organic, blue is for recyclable materials, and black is for garbage. We evaluated a high-fidelity prototype to get a feedback on the usability and how we can improve the app. 100% of the participants like the app and they're willing to use it if it is available. 75% of the participants like the games. And we got 3 suggestions. They wanted the daily tracker screen separate from the calendar view. As you can see in the demo page, there is a calendar view on top and the daily tracker on the bottom. And the participants wanted to have a daily tracker separately where they can say no plastic bag day, or they can choose whether they reused or recycled the food waste, plastic or glass or paper. The users wanted a demo screen of a video where they can get to know how to use the app. This demo can be shown when the user is logging in for the first time, or they can view it anytime when they are confused on how to use the app. The third is the guide. This is the local pamphlet which is provided by the Halifax Regional Municipality on how to dispose each type of waste. This recycling guide differs from city to city. Some cities will have 5 types of waste, some will have just 2. So the local recycling guide is provided to the user based on their current location. And other feature is what goes where. The user can type an item which they don't know how to dispose. Say, for example, they have a battery which they don't know which bin they have to drop it in. They can search it here, or they can click on the camera button to just take a picture of the item so that we can use object recognition and identify the object and suggest them how to dispose the item. To conclude, we conducted a systematic review of 148 mobile applications that are related to sustainable waste management across several domains, and we designed a high fidelity prototype using iterative evaluation and feedback generation. In future, we want to conduct a usability study with large number of participants on the usability of our mobile application, and we want to investigate the effectiveness of app. These are the references. Thank you.